Far beyond the boundaries of our solar system, scattered across the galaxy, thousands of alien worlds orbit distant stars. Some are rocky planets like Earth. Others are frozen giants drifting far from their suns. And some are so strange that they challenge everything scientists thought they knew about how planets form. Over the last 3 decades, astronomers have discovered more than 5,000 planets orbiting stars beyond our solar system. These worlds are known as exoplanets. Many of them are wildly different from anything found in our own planetary neighborhood. Some orbit 2 stars at once. Others are covered in global oceans hundreds of kilometers deep. A few are so hot that their surfaces glow like molten metal. But among all these discoveries, one type of planet continues to puzzle scientists more than any other: the hot Jupiters. These are enormous gas giants, similar in size to Jupiter. But unlike Jupiter, they orbit extremely close to their parent stars. In some cases, they complete a full orbit in just a few days. Temperatures on these worlds can exceed 1,000 degrees Celsius. Their atmospheres are blasted by intense radiation and powerful stellar winds. According to traditional theories of planet formation, these planets should not exist where they are found. Yet astronomers keep discovering them. And recently, scientists identified an exoplanet so unusual that it may force researchers to rethink how planetary systems form across the universe. The story begins with how planets are believed to form in the first place. When a new star is born, it forms from a collapsing cloud of gas and dust inside a giant molecular cloud. And as gravity pulls the material inward, the center of the cloud heats up and eventually ignites nuclear fusion, forming a young star. But not all of the surrounding material falls into the star. Instead, much of it spreads out into a rotating disk known as a protoplanetary disk. Inside this disk, tiny particles of dust collide and stick together. Over time, these grains grow into pebbles, then rocks, and eventually into massive bodies known as planetesimals. Through countless collisions and gravitational interactions, these planetesimals merge into larger objects. This gradual process eventually forms full-sized planets. This theory, known as core accretion, explains how rocky planets like Earth form close to their stars, where temperatures are high and only heavy materials like metals and silicates can condense. Off farther away from the star, where temperatures are lower, ice and gas can accumulate around large planetary cores. This is where giant gas planets like Jupiter and Saturn are thought to form. But there is an important limit within this process. Gas giants require enormous amounts of hydrogen and helium gas to form their massive atmospheres. That gas is only available in large quantities in the colder outer regions of a planetary system. This means that massive gas giants should only form far away from their stars. Yet hot Jupiters appear in exactly the opposite location. They orbit incredibly close to their stars, sometimes closer than Mercury orbits the Sun. This contradiction has puzzled scientists ever since the first hot Jupiter was discovered in 1995. That discovery involved an exoplanet called 51 Pegasi b, a gas giant orbiting its star every 4 days. Since then, astronomers have found hundreds of similar worlds. But one recently discovered exoplanet appears to push this mystery even further. This planet, known as WASP-121b, is one of the most extreme hot Jupiters ever observed. Located roughly 850 light-years from Earth, this giant planet is about 1.8 times the size of Jupiter, but significantly less dense. It orbits its star at an incredibly close distance, completing one full orbit in just about 30 hours. At this distance, the planet is so close to its star that its atmosphere is being stretched by powerful tidal forces. In fact, scientists believe the planet is slowly being torn apart by its star's gravity. Temperatures in the planet's atmosphere exceed 2,500 degrees Celsius, hot enough to vaporize many metals. Observations suggest that the atmosphere contains vaporized iron, magnesium, and other heavy elements drifting through superheated clouds. Powerful winds race across the planet at thousands of kilometers per hour, redistributing heat from the day side to the night side. But the most puzzling part of this discovery is not just the planet's extreme environment. It is how the planet ended up there in the first place. According to standard models, a planet this large should have formed far from its star, beyond the region where ices can condense. That region is often called the frost line. Beyond the frost line, solid ice particles can accumulate quickly, allowing massive planetary cores to grow large enough to capture thick atmospheres of gas. Inside that boundary, forming such a massive planet should be nearly impossible. Due to the intense heat from the nearby star would prevent gas from accumulating in large quantities. Yet WASP-121b sits deep inside this supposedly forbidden region. This raises an important question. Did the planet actually form there? Or did it form far away and later migrate inward? One possibility involves gravitational interactions with other planets. If multiple giant planets formed in the same system, their gravitational forces could disturb each other's orbits. Over time, one planet might be pushed into a highly elongated orbit. As the planet repeatedly swings close to its star, tidal forces gradually pull it into a tighter circular orbit. Eventually, the planet becomes trapped extremely close to the star, creating a hot Jupiter. Another theory involves interactions with the protoplanetary disk itself. In this scenario, a young gas giant forming in the outer disk could slowly spiral inward due to friction with surrounding gas. This process, known as planetary migration, may allow giant planets to travel enormous distances before settling into their final orbits. However, these explanations do not always match the extreme conditions seen in some hot Jupiter systems. Some planets appear too close to their stars, or their orbits are tilted at unusual angles compared to the rotation of their star. These unusual configurations suggest that additional processes may be involved. Studying planets like WASP-121b helps scientists test these ideas. Using powerful telescopes, astronomers can analyze the planet's atmosphere as it passes in front of its star. During these events, known as transits, a small portion of starlight passes through the planet's atmosphere before reaching Earth. Different molecules absorb specific wavelengths of light, leaving distinctive signatures in the star's spectrum. By analyzing these signatures, scientists can determine the chemical composition of the planet's atmosphere. These observations have revealed an incredibly complex environment on WASP-121b. Evidence suggests the atmosphere contains water vapor, exotic metal clouds, and possibly even titanium oxide, a compound capable of trapping heat and creating dramatic temperature inversions. Such extreme chemistry provides valuable clues about how the planet formed and evolved. But it also highlights just how strange these alien worlds can be. Hot Jupiters represent only a small fraction of known exoplanets, yet they have played a huge role in shaping modern planetary science. Before their discovery, scientists assumed that most planetary systems would resemble our own. But the universe turned out to be far more diverse. Each new discovery reveals unexpected types of planets, strange orbital configurations, and atmospheric conditions unlike anything seen before. These findings are forcing astronomers to refine their models of planetary formation. Theories that once seemed solid must now account for the incredible diversity of worlds scattered throughout the galaxy. And with new telescopes now studying distant planets in unprecedented detail, Even more surprising discoveries are likely waiting ahead. The powerful James Webb Space Telescope is already analyzing the atmospheres of several hot Jupiters, searching for chemical clues about how these worlds formed. Future observatories may even detect smaller planets with conditions similar to Earth. Each observation brings scientists closer to understanding how planetary systems develop across the universe. And perhaps one day, these discoveries will reveal not just strange alien worlds, but environments capable of supporting life. For now, planets like WASP-121b serve as powerful reminders that the universe often refuses to follow our expectations. Worlds that should not exist continue to appear in telescope data. Planets orbit in places where theory says they cannot survive. And each new discovery pushes the boundaries of human knowledge a little further. Somewhere among the billions of stars in our galaxy, countless other worlds are still waiting to be found. Some may resemble Earth, others may be stranger than anything we can imagine. But every one of them carries another piece of the cosmic puzzle. And with each new exoplanet discovered, humanity moves one step closer to understanding how planets, and perhaps life itself, emerge from the vast chaos of the universe.